So we have Ash, it's our man, and we would like to exhibit as many paintings as possible in his showroom. And of course, he has a limited budget. I'm going to show you all the constraints. These are the name of artists, the pieces of art, and the description of pieces of art. It's important because in the constraints we have to understand to which category the piece of art appertains. The prizes, of course, and this is the first sub-question, okay? As I told you before, Ash has $4 million to fund the exhibit, so given the piece of art available, we are going to use the binary integer programming to solve our problem. So just to introduce binary integer programming, so binary, it means that the variables have the binary form. So we are handling with the situation of yes or not decisions. It's integer because the variables are restricted to be integers, of course. And so here we can observe our goal is to maximize the pieces that Ash can display in his exhibition, and this is the binary form of the many variables. That is 1 if it can display the piece of art, 0 if it cannot. Okay? These are the constraints. We have a lot of constraints. I'm not gonna explain all the constraints, but at least in binary integer programming we have two kinds of constraints. The first one, it's the mutually exclusive alternatives, in which we have just one group and we have just one decision for all the members of the group, like for example this one or this one, and the other alternative is the contingent decisions, in which the decision depends on the previous one, like when you have the conditional if I cannot find it, skip the other one, like this one, in which the condition is met above the previous one. Yes, go on. And this is the answer of the first sub-question. The 4 million are not enough to exhibit all the pieces of art that we listed, that we show you before. And moreover, because the sum also doesn't cover the requirements that are included in the constraints.
It's the second question. The different is different from the previous one. It removed the 4 million budget limit, and instead it add a new constraint about the pieces displayed should at least 20 pieces, and so we are going to examine the minimized cost of this objective function, which is the x means the binary variable. If it's 1, it's displayed, and 0 not displayed, and p means the price of each one. So this function is the total cost of the display. And we can see we run the Excel solver and we solve the optimal total cost is 5,525,000. And the above is the chosen pieces. And the third one, the third question is they find the sponsor who can pay the amount above exceed the 4 million budget. So, but it's under the condition that all the pieces of all the pieces of retard should be displayed on the gallery. So we are going to see what will change the median amount of the median total cost, and it's also the objective function. And we also run the Excel solver, and we find out the result is the 5,975,000. And so the sponsor, which means is also the patient, has to pay 1,975,000. Yeah, that's the result of our presentation of the project.
You should applaud now.
I would say that these two questions is quite different. The first one is quite easy. That you just made the decision that we score the ratio, you just use 0, 1, and that's it. For the example, you're gonna have the more complex because you're gonna have the condition that you need to select this one, not select that one, or you need to select all of these. Or if you select this, you have to at least have another one, at least 2 pieces or something like that. So it's quite make the problem more complex, just like your exam, right? Okay. So again, I think it's. I hope that you get the experience for the integer, where you can see that actually it's more useful in the real world for the integer. Because in the case that you're gonna make the selection, right? So 0, 1 integer is shows that the problem one. Okay, thank you. And that's it for today. Okay, we're gonna continue next class for doing the example together. Okay, one more thing for the queuing is that you need to practice, especially using the calculator. Okay, because the problem of queuing, you can have like a power 3, power 4, power 5, something like that. So if you use the calculator, that's very simple. The simple one that the big, like the big thousand they're using. So you're gonna, you're gonna lose. So scientific calculator may be, better. Okay, so the one problem that I see a lot because you're going to have the very complex formulation and formula, and when you're using the calculator, you do draw. Right? So we're going to practice the next week. Well, this is for today. Thank you for your attention. See you next week.